Now in this lecture we find the area, moment of inertia of a triangle. So this is a triangle. Now this is base B and height of this triangle is H. Now this is line AB passing through the base of the triangle. So in this, first of all we will find the moment of inertia about this line AB, and then we will transfer it to the centroidal axis parallel to it. So first of all we will find the moment of inertia of this triangle about line AB. So for this we have taken this elemental strip of thickness dy at a distance y. So this is x. So now the area of the strip is dA equal to x into dy. Now this x by the similar triangle method, x upon b is equal to h minus y upon h, ratio of the similar sides. So x upon b is equal to h minus y upon h. X upon b is equal to h minus y upon h. So now x is equal to b into h minus y upon h, or this is x is equal to 1 minus y upon h. So now putting this x in the formula of area dA, x into dy. So this is equal to b into 1 minus y upon h into dy. This is the area dA. Now this moment of inertia of this elemental area about the baseline AB. So this elemental area is at a distance y from AB. This elemental area dA is at a distance y from AB. So we find out the value of IAB is equal to y square into dA. Second moment of area of this y square dA, or for the whole figure, whole triangle about AB is integrated between the limits 0 to h. Between the limits 0 to h. Now put the value of dA. So 0 to h, y square, and value of dA is b into 1 minus y upon h into dy. This is the value of dA, b into 1 minus y upon h into dy, or this is equal to 0 to h multiplied inside. So this will give you y square minus y cube by h into dy. Or on integrating it, v is outside and this is y cube by 3 minus y to the power 4 upon 4 h. Limit is 0 to h. Now putting the limits, v is, on putting h cube upon 3 minus h to the power 4 upon 4h, or this is equal to b into h cube by 3 minus h cube by 4. H will cancel out this, so h is equal to the power 3. So on solving this, this is equal to b h cube upon 12. So this is IAB, BH cube upon 12. Now transfer this IAB about XX, centroidal axis, XX centroidal axis. So by putting this in the parallel axis theorem. So by parallel axis theorem, the centroidal axis of this triangle, centroidal axis of this triangle is at a distance h by 3 from here, h by 3 from here. Suppose this is the centroid and centroidal axis is at a distance, because we know the centroid at a distance h by 3. Centroid is at a distance h by 3 from this line. So this is the distance. Now we have to transfer the moment of inertia about AB to this x-axis, x. So by the parallel axis theorem, by parallel axis theorem, IAB is equal to IXX plus area of the triangle into distance between them ka square. So this IAB is BH cube by 12. As we have find earlier, IAB is BH cube by 12. So on putting the value, IAB is equal to BH cube by 12 is equal to IXX plus area of the triangle 1 by 2 into base into height and into the square of this, h square by 9. So this is equal to BH cube by 12 is equal to IXX plus this give the value BH cube by 18, BH cube by 18, or this IXX is equal to BH cube by 12 minus BH cube by 18. So this will be equal to 36 is the LCM and 3 BH cube minus 2 BH cube. So this will give you BH cube by 36. So this is the IXX. So we can transfer the value by parallel axis theorem. Parallel axis theorem. So by applying parallel axis theorem, we can transfer the value IAB at the centroidal axis XX. So IAB, we have received that IAB is equal to BH cube by 12, and this on transferring to centroidal axis XX, it will be BH cube by 36. Okay, thank you. Now next is the moment of inertia of a circle. So for a circle, we draw this circle, and these are the centroidal axis. This is the XX and this is YY. Now in this circle, we will take a elemental area like this. So this elemental area is, this angle is theta and this is d theta, and it is the radius of the circle is capital R, and this is at a small r distance, and the thickness, this thickness is dr. So at a radius small r, dr thickness is taken. So now this angle is d theta, and the radius is, this radius is r, small r. So this will be equal to r d theta. So strip is like this. This elemental area is like this. So this is r d theta and this is dr. And this is x-axis and this is y-axis. So now the distance of this area from here is r. So we are requiring distance from x-axis and from y-axis. So this distance is from y-axis and this vertical distance is from x-axis. So this vertical distance will be equal to, because this is theta, so this vertical distance will be equal to r sine theta, and horizontal distance will be equal to r cos theta. So horizontal distance will be equal to r cos theta and this vertical distance will be r sine theta, and the area dA will be equal to r d theta into dr. This will be the area. So now area dA is equal to r d theta into dr, and moment of inertia of dA about x-axis is dA into square of this distance, r sine theta. So r sine theta ka square. This will be the moment of inertia about x-axis. About x-axis, this x-axis, about x-axis, moment of inertia will be dA into r sin theta ka whole square. So for total circle, we will integrate it. Now on putting the value of dA is r d theta dr. So on putting this value r d theta dr into r square sin square theta. So now we have to integrate it twice, because when we integrate it from 0 to 2 pi, from here to again complete round equal to 0 to 2 pi for making a ring, and this ring will be expanded from 0 to capital R, from 0 to capital R. So to fill this whole area, we have to integrate it twice. So first we will integrate it 0 to 2 pi, then from 0 to R. So now on integrating, we know that sin square theta is equal to 1 minus cos 2 theta upon 2 by trigonometric function. We can find out the value of sin square theta is equal to 1 minus cos 2 theta divided by 2. So on putting this in here, so from 0 to r, this is equal to 0 to 2 pi, and on putting r square and multiplied by r, so this will give you the value r cube, and multiplied it by sin square theta. So on putting the value of sin square theta, 1 minus cos 2 theta divided by 2. So this will be d theta and dr. Now on integrating, this is equal to 0 to r and equal to 0 to 2 pi, and this 2 is constant, so r cube by 2, and first integrate it. So on integrating with respect to d theta, this will give you theta minus sin 2 theta divided by 2, and this is dr. So these limits can be put here. From here, these limits can be put 0 to 2 pi. So this will give you, on putting the limits, this is 0 to r cube by 2, and on putting the limits, this will be equal to 2 pi, and minus here, when we place 2 pi, it will be 0, and when we place 0, it will be 0. So this is this. Now this is dr. So on integrating it, 2 pi divided by 2 into r की power 4 upon 4, and limit is 0 to capital R. So on putting the limit, this will give you the value pi r की power 4 upon 4. This is Ixx. So this is Ixx. Similarly, we can find out Iyy. So this Iyy, on finding Iyy, this will be equal to again dA into x square, or dA is or on integrating it twice, 0 to 2 pi and 0 to r, or this will be equal to, on putting the value, 0 to r, 0 to 2 pi, on putting the value of dA is r d theta dr, and this value x is r square cos square theta. So now this is equal to 0 to r and 0 to 2 pi, and this r square and r is r cube d theta dr, and in place of cos square theta, 1 plus cos 2 theta divided by 2. Now on integrating 0 to r cube, 2 is taken outside, this 1 plus cos 2 theta into d theta dr, and integrating it 0 to 2 pi. Now on integrating 0 to r square r cube by 2, and on integrating theta plus sine 2 theta divided by 2, and the limit is 0 to 2 pi. Again, this is equal to 0 to r cube by 2 multiplied by, on putting the limits, 2 pi plus 0. So this is equal to 0 to r cube by 2 here dr. So this will be equal to r to the power 4 upon 4 into 2 pi. So this 2 is cancel out, and pi r to the power 4 upon 4, and the limit is 0 to capital R. So this will give you the pi r to the power 4 upon 4. So I by y. So I by y and Ixx both are equal in case of a circle, equal to pi r to the power 4 upon 4. In case of a circle, area moment of inertia Ixx is equal to Iyy is equal to pi r to the power 4 by 4. Okay, thank you. Now the moment of inertia of a semicircle. The moment of inertia of a semicircle. So now this is a semicircle. So this is the axis AB, and similar to circle, we have taken this element at a r of thickness dr. So this is d theta, and this angle is theta. So this is r d theta. So as earlier, this area dA is equal to r d theta into dr. Now the distance of this area from line AB, is r sine theta. From line AB is r sine theta. So now the moment of inertia for dA about AB is IAB equal to integration 2 times as earlier dA into square of this distance r square sine square theta. So on putting the value of dA, r d theta dr into r square sine square theta. Now here the limits from is 0 to pi. Limits are 0 to pi. Earlier it was from 0 to 2 pi in full circle, but in half circle it is 0 to pi. And this ring is expanded from 0 to r. So radius is same as 0 to capital R, but the angular limits are 0 to pi. So this is 0 to pi and this is 0 to r. So now similarly as earlier 0 to pi, this is r cube d theta dr, and this sine square theta can be written as 1 minus cos 2 theta upon 2 as earlier, and again this is 0 to r, this 2 is with this r cube by 2, and on integrating it as earlier theta minus sine 2 theta divided by 2, and limit is 0 to pi, and this is dr. So on putting the limits, this is equal to 0 to r and this is r cube by 2, and on putting the limits, this pi is here and minus sine pi and sine 0 is also 0. So this is dr, and this pi by 2 is taken outside and r cube dr. So this will give you as pi by 2, and this is r to power 4 upon 4, and limits are 0 to capital R. So this will give you the value pi r to power 4 upon 8 for a semicircle about diametral axis IAB. This is diametral axis IAB. Similarly, we can find out as earlier along this YY. This YY. So along this YY, similarly IYY will also be pi r to power 4 upon 8. Now it is about IAB, but we have to find about IXX. So for this semicircle, this is line AB. This is line AB, and centroid is lying at this line at a distance from here 4r by 3 pi. We have studied in the chapter of centroid that this centroid is lying from here at a distance 4r by 3 pi. So now we will transfer it about xx. So it will give Ixx by the parallel axis theorem, and the distance between the parallel lines is 4r by 3 pi. So now on putting by parallel axis theorem, IAB is equal to Ixx plus A into distance का square 4r by 3 pi का whole square. Now on putting IAB is pi r की power 4 upon 8. So pi r की power 4 upon 8 is equal to Ixx plus area of this semicircle of radius capital R. Area of this semicircle is pi r square by 2. Pi r square by 2. And now on squaring it, 16 r square upon 9 pi square. So this will give Ixx is equal to pi r to the power 4 upon 8 minus this r to the power 4 and this 16 and this 2 cancel this 16 by 8. So this is 8r to the power 4 upon this 9 and this pi cancel this power, so upon 9 pi. So on solving and putting the value of pi, the final answer is 0.11 r to the power 4. So this is the moment of inertia of a semicircle about its centroidal axis. So centroidal axis of this semicircle is, this is the centroid. So this is the semicircle centroidal axis. One is x-axis and this one is y-y. So this centroidal axis is along y-axis and it is the diametral axis. So Iyy is pi r की power 4 upon 8 and Ixx is 0.11 r to the power 4. Okay, thank you. Now the moment of inertia of a quadrant, that is quarter circle. So here also the method is same as in circle and semicircle, only the difference of limits is there. So this is a quarter circle, and for this also we will take a elemental area like this. The thickness is r d theta because this is angle d theta, this is theta, and it is at a distance r, and this is dr. So for this the distance is similar as earlier, r sin theta, and for this r cos theta. Now again the area is dA is equal to r d theta into dr, r d theta into dr. Now as similar as earlier, moment of inertia of this dA is equal to about this line AB, about this line AB. IAB is equal to, here again the limits from 0 to pi by 2, because this is a quarter circle. So only limits are changed from 0 to pi by 2. Remaining is same as earlier. So 0 to r, and this is 0 to pi by 2, and this is as earlier r d theta into dr, the value of dA, into r square sine square theta. So on expanding 0 to r, and this is 0 to pi by 2, and again it is r cube and d theta dr, and in place of 1 minus cos 2 theta upon 2, and this is equal to 0 to r, this is r cube by 2, and this on integrating theta minus sine 2 theta divided by 2, and limits it's 0 to pi by 2, and this is dr. So now on putting the limits 0 to r and r cube by 2, on putting the limits, this will give you pi by 2, again pi by 2 into, on putting this pi by 2, sine pi is 0 and sine 0 is 0, and this is dr. So on again on integrating this 1 by 2 into pi by 2, and this 0 to r cube into dr. So this will give you pi by 4 into r to the power 4 upon 4, and limit is 0 to capital R. So on putting limit, this will be equal to pi r to the power 4 upon 16. Pi r to the power 4 upon 16. This is IAB. Similarly, ICD. This is for, this is CD. So again ICD equal to IAB, as we have derived pi r to the power 4 upon 16. So IAB is equal to ICD. Now we will transfer it to the centroidal axis. So we know the centroid of this quadrant is lying here. So these are the centroidal axis. This is x-axis, and centroidal axis, this is y-y. So we know that this distance and this distance both are equal. This is 4r by 3 pi, and this is also 4r by 3 pi. So for this is about this line ix and about this iyy. So for this ix, we will transfer IAB to this, and for iyy, we will transfer ICD to this. So because the distance is same, so the answer will be the same. So we will derive for 1. So by parallel axis theorem, IAB is equal to IXX plus area into 4r by 3 pi the whole square. Now on putting the values, this IAB is pi r to the power 4 upon 16. So this is pi r to the power 4 upon 16 is equal to IXX plus, this is pi r square by 4, because it is a quarter circle, into this 16 r to square upon 9 pi square. So this IXX will be equal to pi r to the power 4 upon 16 minus this r to the power 4, 16 r to the power 4, and this is divided by 4 into 9, 36 pi. Because pi, this power is cancelled out by this pi. So 4 into 9 is 36, and this is 16 r to the power 4 upon pi. So on solving, this will be equal to 0.11 r to the power 4 divided by 2. So Ixx, this will be 0.11 r to the power 4 divided by 2, and it is also equal to Iyy because the distance is similar. So this is 0.11 r to the power 4 by 2 on solving this.